Up until now, you might have used sine and cosine to find the sides in a right angle triangle, like this. Or you might have used sine and cosine in the unit circle with angles in degrees. In this video, we're going to move away from that and use sine and cosine as functions. The first step in doing that is to introduce radians. Radians are defined as the circumference of a circle sector divided by the radius, and that is the angle in radians. So if you have a circle sector, radians are defined as the circumference of a circle sector divided by the radius, and this is the angle in radians. And this is defined using the geometry of the circle instead of man-made numbers like degrees. So we're going to use radians from now on as inputs in sine and cosine. If you have an angle in degrees, say alpha, and you want it in radians, the way to do this is to divide by 360 degrees, then this becomes unitless and tells you the amount of a circle that A sweeps, and you multiply it by 2 pi, which is the radians of a full circle, and that would give you the angle in radians. Now if you have an angle in radians and you want to go back to degrees, then you would divide the angle in radians divided by 2 pi. This is the whole circle in radians. Here you would get the fraction of the circle that the angle sweeps times the whole circle in degrees. Then you would get the angle in degrees. So some examples: 30 degrees corresponds to pi over 6 in radians. 45 degrees corresponds to pi over 4 in radians, and 60 degrees corresponds to pi over 3 in radians. Now, just as you might remember that a quadratic function can have a general form, for example, y is equal to ax squared plus bx plus c. This is a general form of a quadratic function. The general form of sine is y is equal to a times sine of theta plus delta plus b. So when you multiply a sine function with a constant, then you would just scale every value that sine function gives with a constant. This means that a changes the amplitude of the sine function. So a sine function, sine of theta, has values between -1 and 1, but when you multiply it by a, you would scale these numbers, all the numbers that sine function gives, and the amplitudes would be between -a and a. So if a is larger than 1, you would increase the amplitude, and if a is less than 1, you would decrease the amplitude. The constant delta translates the sine function to the left or to the right depending on the sign of delta. Let's take a sine function. The argument is 0 when theta equals to 0. So let's say we add a delta to the argument. We would have sine of theta plus delta. The argument is 0 now when theta is equal to negative delta. You can think about this as the starting point of the sine function moving back to negative delta. What happens if you subtract a phase delta? You would have sine of theta minus delta. Then the argument is 0 when theta is equal to delta. How you can think about this is that the starting point of sine function has moved forward with the phase of delta. Let me try to draw these. We would have something like this. This is the sine function. This is the sine of theta minus delta. And this is the sine of theta plus delta. Now the constant b would just shift every value of the sine function up or down depending on the sine of b. The most noticeable is sine of 0, which is 0. Now if we add constant b, we would have sine of 0 plus b, which equals b. So the whole sine function is translated up or down the y-axis, but it's easiest to see for the 0 argument. And now we can see that the sine function is just between 1 and -1, but sine of theta plus b would be between 1 plus b and -1 plus b. So if we try to draw this, at the time of the recording, I forgot to mention that the general form of a sine function also has a constant nu. So the role of nu multiplied by the variable is to change the frequency of the sine function. So imagine we have a sine function, sine of theta, then a period is 2 pi. For sine of nu times theta, we have 2 pi divided by nu period. And let's just say the names of these constants. A is the amplitude, nu is the frequency, delta is called the phase, and b is just called the constant. Let's have an example. Sine of x is equal to 1 over square root of 2. From the unit circle, we can see that the angle could be pi over 4 or 3 pi over 4. So let's start with solution 1. So x is equal to pi over 4. But we also said that if we go around the circle, the unit circle, 2 pi radians, a whole circle, we would come back to the same point. So if we go around one turn, we would come back to the same point. If we go around 2 turns, we would still come back to the same point. However many turns we take, if we go a complete turn from pi over 4, then we would come back to the same point. So we would have a solution is pi over 4 plus 2 pi times n, which is the amount of complete turns we have taken. So we have infinite amount of solutions. So solution 2 is for the second angle, 3 pi over 4. So x could be 3 pi over 4 plus 2 pi times the number of complete turns we have taken. So these two are infinite solutions to this equation.